All right, guys. Good everyone. This is Team TSS, and this is our project for the challenge GridSense EV. So the problem statement: Nigeria EV ecosystem is flying blind. EV drivers drive to charging station with no power, no way to know before leaving, no way to know before locating it. Fleet operators, no central visibility into which station their network are actually working. And for investors and government, no data on where demand is unmet or grid quality is insufficient. So this is why we build GridSense. The solution, the ground truths are from real hardware. So on the top of our solution, we have our smart meter, so which reads the live voltage, frequency, and power quality every 2 seconds from the grid, either the solar grid, the hydroelectric grid, and any grid at all. Then we have our AWS IoT pipeline, so which the ESP32 streams telemetry data from the hardware to the AWS DB, Dynamo DB. Then we have our AI bedrock. So it generate plain English for operators and alert the operator where there's anomaly or when there's an anomaly detected on the grid or on the hardware. So this is the architectural diagram of our solution. Like I said, the first layer is the sensing layer. This is the most important layer for our solution. This is the sensing layer where we have the smart IoT meter, we have the ESP32 and all that. So then this is then published to the AWS IoT core using the which is the layer 2 injection. Then the O2 streams to if there is an anomaly from our Lambda, the intelligence aspect, it gets noticed. But from here, from the Dynamo, it received the data and it published it to the end users and all that. So I will not go much into this, just the diagram above here. Then how does it work? The sensing layer, the ingestion layer, like I said before, and also the user layer. So the market opportunity, like we all know, there's the EV market in Nigeria is projected to hit 2.1 trillion naira by 2030. We have about 774 local governments in Nigeria with zero EV charging coverage and many more. So without further ado, let's get. All right, so this is our hardware setup right here. So this is our IoT smart meter. So this is a very special type of meter. It is a three-phase multifunctional meter. So this meter can be placed on energy grids, any type of grid, solar grid, or hydroelectric power grids, any type of grid at all. So it's a three-phase multifunctional grid. You can see right now, I connected it to, so I have my own mini grid here. So I just connected it to an extension. It's a three-phase, but I connected it just to a single phase. So the voltage reading now is just for the single phase. So you can see the current, the voltage here is 247 and all that. So it can read other parameters, voltage, current, average current, power factor, and all. So also here we have our microcontroller here. So we are using the ESP32 S3 board. Then we have our RS485 here. So this is like a communication bridge between the IoT smart meter and the ESP32. So what this does is that this communicates with the IoT meter and then send the parameters to the ESP32, which is then published to our DB, to the AWS Dynamos database. So you can see here from my screen. So you can see the data coming up here. So you can see it is reading the current, the voltage, and every other parameter. So it is reading it. Okay. Now this is our app. We project it to be a mobile app. That's why we have it like this. But for the sake of this, the timeline for this hackathon, it's a web simulated app. So now I will enter into the app. So like you can see on the dashboard here, the driver, I can see their energy, battery temperature, climate, and all that. So I will come back right here. This is for the simulation. So we are going to query this in the column. So we move to that section. This is the map. So right now, so this is our map here. These are just some of these are simulated data, but one important one here, this right here, is a real data. This one is from the IoT platform. Like I said, the mini grid I have here with me. So you can see it is reading the value, the voltage, the frequency, and all that. So this is the EV station we set up here for this hackathon just to demo how this will work. So yeah, so for now, what I'll do now is that just to show you how it will work, I will switch it off. So I will switch off the this thing here, and this will go offline. So it is fast. It take about less than 2 seconds for that to happen. So I will do that now, and you should see it here. It will be offline. So I'm switching it. So right now I'm switching it off. As you can see, I'm removing it from here. Yes. So I've switched it off. Let's just give it a little. Okay. Now you can see it is saying offline, zero frequency, zero drive, and zero voltage. So what I can do now is that I will power it on again. So as you can see, right there, I'm powering it on again. Okay. So I will power it on again. But before that, let me show you. You can see it's reading 00 here. So if I power it on again, you see it's coming up, and then it should show right here that it will increase. Yes, you can see the power is back on because of that. So everything is going to our AWS platform. So that is that for that. But others we have here, these are just simulated stations right here. So another interesting thing here is that we have this blue dot here as a driver. So this is John. This is the driver. So right here, John is trying to charge. Let's go back here. John is at 90, but let us reduce John battery to about 50. So what John will do, or 30, let's say 30. So John is trying to charge his EV. So what John can do is that John will check um for nearest suitable place to charge. So what will happen is that we have this algorithm on our back end that calculates the queue driver, their waiting time. You can see right here the queue driver here is 2. If you check other, like the closest one, this one, the queue driver here is 3. If you check others here, the queue driver here is 0. But what this will do is that it will calculate the driver distance to the nearest station, and then add it up to their waiting time. That is their waiting time it will take for these two drivers here that are charging their EV to complete their charging. So it will calculate it and check if this for him, if traveling from here to here, the time is lesser than for him to charge from here with the driver, it will recommend the driver to get here. But if it is shorter, it will just tell the driver to get here. But as you can see here, the distance here is shorter than the distance here. So what I will do is that I will click on this nearest suitable location, and it will triangulate it. As you can see, it's give the route for the travel, the fastest route for the driver to travel. So let me zoom it closer a little bit so the driver can travel here. So what I'll do now is that I will to display this very well. What I'll do is that I will switch off this Yaba fleet. I will switch it off. So let me close this for now. I will switch it off, and I will try to get in. So I'll go to my back end off. So let me go back to the web. Yeah, this is where we are. So you can see we have turned this off now. As you can see, we have turned this off. Yes. So Yaba right here is off. So Yaba is offline here. So if I try to get the nearest suitable place for the charger, for the driver to charge, let me make sure this is back to 30% because to affect the calculation. So if I get the nearest suitable distance here, it will make sure to get the nearest place. So as you can see, the nearest place is also triangulated to is here. This Surulere EV Plaza. So we can see it right here. There's another place here, but if you want to check the reason why I did this, there's zero driver here. There's about 3 to 4 charging station here. But for this one also, there are 3 drivers here and all that. So that was the reason why I triangulated to this place. So that is that. And we have the activity page for the driver to see the activity, their charging duration, and we also have the profile page. Now, moving on, um, so we also have this dashboard here. So this dashboard basically is for operators, for investors, or for policymakers for them to see the data. So if the IoT meter is installed in different grid, so they can check here the grid here in Lekki, in Abuja, in Port Harcourt, Victoria Island, their activities and every other thing, the voltage spike, the downtime, the uptime. And also they can check the market opportunities. They can check which area is more congested, which area needs much uptime. You can see for this place here, it's saying that Victoria Island is very, very congested. They need more EVs there. So that is what this dashboard here is for. So we also have this policy planning. Same thing. They can check disco grid stress zone. You can see Ikeja is stress. Same thing with Eco Hotel. So and that's what we have right here. So thank you very much.